Namaskar, this is Arun from CSEB, and today I'm here to talk about ultra-wideband networking, which is also called as UWB networking. So, as part of my thesis for network subject in S5, I'm trying to explain ultra-wideband networks in a brief manner using a small PPT that I've made. So, moving on into the topic. So, ultra-wideband is basically a radio technology that is used for wide range of frequency channels that have low energy consumptions and short ranges, such as the Bluetooth and Wi-Fi, etc. Not only short ranges, but how many of you know that ultra wideband networking networks can also be used for higher ranges and on a wide range of frequencies? We'll discuss about this later in the presentation, but now for now on, let's move on to the next slide. 500 megahertz. The term UWB is used for a bandwidth that is larger or equal to 500 megahertz, and that is why I've made a small slide separately on 500 megahertz, which being the larger minimum requirement for ultra wideband frequencies. So anything that is larger or equal to 500 megahertz or a fractional bandwidth greater than 20%, where the fractional bandwidth is equal to BW by FC, where FC is the central frequency. This is what we actually call ultra wideband networks as. So UW actually requires large bandwidth of 500 megahertz, which makes it more accurate and faster at the same time, using a small radio wave frequency. Now, coming to the next one, we have different types of different usages based on location over here that is utilized by UWB. But when we talk about ultra wideband networks, they can basically be leveraged to detect the location of people, devices, and assets, with unrivaled precision, like any other communication techniques that are actually protocols that are currently in use, like the Bluetooth or the Wi-Fi. UWB can also be utilized to transmit data between and through devices, through two devices, or not necessarily two devices, or between any connected devices through radio waves. So it makes it much easier. It does so basically by with short nanosecond pulses over an ultra wide range of networks or range of frequencies. So that makes it much faster and accurate at the same time, like we discussed before. Now, moving on to the next slide, we have several facts about UWB over here. UWB, as I previously said, it's a short form for ultra wide band networks. So, ultra wide band network technology has actually been around for decades now. It's said to be around 132 years old. So, it was discovered 132 years ago. So, since then it has seen multiple usages of, we have seen multiple usages of UWB in different sectors and fields. Basically, in technologies where we are actually using where we are actually using UWB, majorly includes the military, because we need location services, the tracking, the radars, etc., from a remote location to shifting bases and all. So UWB plays a major role in the military segment, in the form of radars and as remote heart monitoring systems, as well as we discussed. So UWB basically, it saw limited use in military radars, as it was actually an unlicensed product previously and in military. So communication through UWB channels is the most secure one available till now, being most accurate as well. Come on. Now moving to the next slide. How does the UWB work? Ever wondered how the bats that we see in our locality communicate? We know, right? They communicate through higher frequencies using echolocations, like echo, that the sounds that they make. So bats use echolocation to sense the environment around them. Such is the case with UWB. Being a wireless communication, it uses radio waves, as we discussed. So the UWB pulses, which are also called as the frequencies, or any other form of waves that are transferred, can be used to sense distances between two particular transmitters located at different places in a locality within a certain distance. The shorter the duration of the impulse, the more precise the distance measurement will be. So the more accurate and the more precise it will be, meaning it will be more, it works more accurately on a shorter span of distance, or on a short distance. So basically, the reason why UWB can so precisely detect location is basically due to its distance-based measurement, via the time of flight that we actually learned in physics. So time of flight basically calculates the location based on how long it takes, for the pulses or the waves to of a radio of radio frequency to travel from one device to another. So that is the reason why it's more accurate in the form of calculating distances, etc. Do you know iPhones are actually equipped with UWB chipsets? We have been using several smartphone devices throughout decades now, almost for a decade. I'm sorry now, but iPhones have actually, Apple has actually invented a U1 chip, which is a chip which is called as U1, specifically for ultra wideband networking, for using across their devices, multiple devices that are available in their network, basically such as iWatch and Apple, the Apple tags, the MacBooks, the iPhones, etc. So iPhones can actually communicate through them in using these using the U1 chipset that they've installed in the mobile which we purchased. So these are used to calculate distances, the measurements, location tracking services, and the introduction of Apple tags, as we know, has been really successful in the last 1 year. So even Apple tags are based on this same technology because they actually precisely tell the location, of the product that we leave the tag to. We'll discuss about this in coming slide. So now, how does the ultra wideband network works in the Apple devices or any other smartphone devices? Not only Apple, but typically every other smartphone brand that is coming out in the market right now, that is coming out huge in the market right now, is trying to establish, is trying to create their own chipsets for ultra wideband networking. Samsung is actually trying to implement these in the coming years. So now let's discuss how these work on a good note. So it's pretty technical actually. The way UWB works is whenever we have two devices that we want to connect on a network or a Bluetooth or an over a wideband network. So once a UWB enabled device is near another UWB enabled device, these two devices will start ranking, which ranking basically refers to the calculation of time of flight, like we discussed in the previous slide, between the two distances that we are trying to connect. So it uses larger channel bandwidth, as we discussed in the very first slide, which is 500 megahertz or more, and short pulses, that is 2 nanoseconds per second. So the positioning, process instantaneously tracks the device's location and then movements in real time by connecting itself to the Bluetooth or to several, other options that are available on the device, and it enables the devices to understand both motion and relative position of the other device. Like one can understand the motion and relative position of the other device once they are connected using UWB. So for UWB positioning, like we discussed just in the before slide, there are two primary aspects and or techniques that are used by the by UWB chips or the chipsets, which is time difference of arrival, that is TDOA, and two-way ranging. When we talk about time distance of arrival, like it's basically, the UWB anchors. There are anchors present in the UWB chipsets that are majorly responsible for the connection facilities that we are experiencing right now. So the UWB anchors are the sensors that are deployed in a fixed position through an indoor space. These sensors detect and locate the transmitting UWB device that we are using, that anybody is using, which we are trying to connect, such as a tracking tag or an Apple tag in this instance. So to work properly, these anchors need to be accurately synchronized to run on time, to basically run on the same clock. So both the devices need to run on the same clock, meaning the time and they should be synchronized in every possible way. So the other one, which is two-way ranging. So TWR, unlike in TDOA, where we have multiple fixed anchors work together, like working together to basically get the connection approved or established. I'm sorry. So, but TWR primarily uses two-way communication between two devices, such as the smartphones, which being the best example for TWR, to sense the distance, the accurate and precise distance between two devices connected on a Bluetooth network. Moving on. These are basically, UWB advantages. Please go through the slide. I'll not be discussing each and every point mentioned over here, but I'll tell you something more interesting. When we talk about the unique advantages that we have by using ultra wideband networking, these advantages have actually led to it swiftly, setting a new standard or trend for the radio frequency technologies throughout the world. It can transmit very high data rates over short ranges, as we suppose, and find out pinpoint exact locations of the users in real time. It also consumes very less power, and this being the major reason, there are smartphone companies and various other technological legends fighting, and they're fighting with each other to prove their excellence in UWB, in installing or creating UWB chipsets. Next slide, the future of AWB. So in a world that revolves around data collection right now, increased visibility and robust actionable ideas or insights from the data that we collect, UWB plays a major role, and that's a game changer for sure. In the world of 5G right now, which is actually planning to roll out in India very soon, and IoT, UWB plays a major role, as both these technologies completely depend on accuracy and precision. Thank you.